My dear students, how are you? I am welcoming you for this lecture number 2, depends upon the current topic, that is the current electricity. As per the first class, you already learnt about the first portions of your the unit 2 as sponsored or as specified by the CHSE in the revised syllabus, not of your the earlier syllabus, according to the revised syllabus. So, we have discussed about what is the meaning of the current, what is the unit, what is the dimension, the drift velocity, its mathematical expression, how it is related with the current, then the Ohm's law and your the resistivity. Up to that we discussed in our the last class. Probably you have make a preparation on that one, and later we are going to discuss about the detailing about your the another topics or the another subjects which are remain. And let us now go to find the current electricity, the unit 2 as per our the syllabus. Next one is your the specific resistance or the resistivity, about which we discussed in our the last class. So, in your the resistivity, whose other name is also your the specific resistance, which is represented by the symbol rho, we already discussed. According to that one, rho is equals to your the RA by your the L. Means this R is your the resistance, A means the area for the cross section of that conducting wire or the substance which we are discussing, and your the L is its the length. So, rho is equals to RA by L. Depending upon this, we already know what will be its the unit and what will be its the dimension. So, for the rho, it purely depends upon your the A, L and your the R. R means for a particular element, that is your the remain same under that conditions, under the different conditions that value may be your the vary. So, this up to your the this specific resistance or the resistivity we have discussed. From here we can draw a conclusion that this rho and the R, they are directly related. Means if the rho will be the more, then the resistance will be the more, and the resistance will be the less, then rho will be less, that we already discussed. Next one, according to our the syllabus, that is your the conductivity. Conductivity, which is according to my symbolization that we are taken in the symbol of your the J. So, conductivity, its parent word is your the conduct. Conduct means to your the absorb. So, a body which absorbs the more or the less, according to that one we will go for its the conductivity. So, this conductivity is equals to the reciprocal of the resistivity. Conductivity is defined as the reciprocal of the resistivity. So, if it is the reciprocal of the resistivity, and this resistivity rho as we have written here, that is equals to your the RA by L. So, this L will go up. So, this is equals to your the L by your the RA, that is your the conductivity. So, if this is the L by RA, you see this G is related inversely with the resistance. Means if the resistance will be the more, then the value of the G will be the less. If the value of the R will be the less, then this value of the G will be the more. So, depending upon that one, the conductivity of a material, we will discuss for the conductivity of a material, and that material is either of the conductor or insulator. Regarding these two we have to first discuss. Insulator, as you know my dear students, that insulator in our own language, that is known as the Kuparivahi, and the conductor, that is your the Suparivahi. Suparivahi means which can conduct very easily. Suppose a thing is conducted very easily, what it indicates? If it is conducts very easily, means the opposition which it provides, that must be your the less. So, if the opposition is less, opposition is nothing but your the resistance. If the resistance will be the less of that material, then we will call that is a good conductor. And if the resistivity will be the more, If the resistive means if the resistance will be the more. If the resistance will be more means its opposition is more. If the opposition will be the more, the thing which to be enter, that magnitude will gradually or the decrease. Therefore, in case of the insulator, the conductivity, it is your the less, and for your the conductor, the conductivity is more, not your. The conductivity is not your, that is your the more, not myself, that is more, more means it is the greater. So if the conductivity will be the greater, then what will happen? It can conduct easily, very much. Therefore, it has your the more conductivity means it is the conductor, less conductivity means it is the insulator. Then comes unit and the dimension. I am writing it U and D, unit and the dimension. So what is the unit? As per my the last class, I said that the unit of your the any physical quantity that purely depends upon its the mathematical expression. Suppose we are going to find the conductivity means your the G. G mathematical expression is your the 1 by rho. So 1 by rho, 1 by rho. This is the fundamental one, 1 by rho. So rho is the resistivity. As per the last class, the resistivity unit is your the ohm meter. Resistivity unit is your the ohm meter. If you will make the practice as I said in the last class, then you can easily remember that the resistivity is your the ohm into your the meter. So this is equals to your the 1 by ohm into your the meter. So if this is the 1 by ohm into meter, this can also be written as the ohm inverse meter inverse. This is its the unit. If we go for its the dimension, so that is equals to the 1 by rho means L by RA. If on the expansion, L dimension is equals to the L, R dimension means the resistance. As we have discussed, resistance you know V is equals to the IR. So R is equals to the V by I, V is equals to the W by Q, and I is equals to the Q by T. So this is equals to W by Q into T by the Q. So W by Q into T by Q. So that is equals to WT by the Q square. So W means the work, its dimension is ml square T to the power minus 2. T is your the time, and this Q, as I said, you can take an as your the Q, or the Q is equals to your the IT. Instead of the Q, you can take your the IT, and if you put this value and rearrange them, then you will find out what is the dimension of its the conductivity. So these two things we discussed. One is the resistivity or the specific resistance. Second one is your the conductivity. Next we will go conductivity, and one is your the conductance. Next one is your the conductance. Suppose we will write in here the symbol of your the M, conductance. So if it is your the conductance is defined as your the one reciprocal of the resistance. Reciprocal of the resistance is the conductance. The symbol is not your the matter, whatever may be the symbol you will write, whatever may be that symbol, but the pronunciation should be your the same for your the original one. So M is equals to your the 1 by R, means 1 by R, R is the unit is your the ohm. If it is will go for your the M case. So reciprocal of the resistance is your the conductance, and the reciprocal of your the conductivity is your the reciprocal of the resistivity is your the conductivity. G is equals to your the 1 by rho. So how you will remember these two? There is a formula for that one. You see, for the conductance it is related with your the resistance, but for the conductivity it is related with your the resistivity. So if you remember the conductivity means it is the reciprocal of resistivity. If you know your the conductance means it is the reciprocal of the resistance. So the reciprocal of the resistance is your the conductance. So in the M case, that is the 1 by ohm. So 1 by ohm, as we have written here, that is equals to your the ohm to the power of minus 1. That means your the ohm inverse. Inverse means in the reverse order. So if ohm you will pronounce and make it in the reverse way, that is equals to your the MHO. that is your the MHO. So, the unit of your the conductance can also be written as your the MHO, and nowadays it is written as your the Siemens. So, if this is the ohm inverse meter inverse, according to this one, ohm inverse is equals to your the mho. So, you can say this is the mho meter inverse. Mho meter inverse, not your meter inverse, mho meter inverse, that is your the mho meter inverse. As I indicated by the finger by that one not, but mho means it is the reciprocal of your reverse of your the ohm. And this ohm, mho, MHO can also be written here the C. So, S, that is the SM inverse, that is your the conductance. So, the definition of the resistance, capacitance and your the conductance, these three we discuss. Next we will go for the effect of the temperature on resistance. So, this is the unit. You can also find out its the dimension, means whatever the dimension of the R, it's to the power of a -1 if you will take for the whole one, then that is it's the conductance. Next very important one is the effect of temperature on resistance or resistors. Effect of a temperature on your the resistor. So, as we discussed in the earlier class, you know that the resistance R is equals to your the V by I, that R we have written ml by Na E square tau. I have written in the last class, R is equals to ml by Na E square tau. Here m, n, e, tau, if they are the constants, and therefore, R is proportional to L and the proportional to A. So, if R is proportional to L, L means your the length. If the length to be your the vary, when the temperature to be your the vary, as we know, suppose we have a metallic conductor and it to be supplied with the temperature. If the temperature will go on increasing, and as per our the general knowledge, we come to a conclusion that the length of that conductor is go on here the increasing. As I said in the last class, like the examples which we are seen on here the blacksmith. If you will go to your the blacksmith and you will give here the certain rod and make it in this form, then you will find that the blacksmith is inserting that one inside your the hot chamber. After some time, he is hammering to that one. So, by taking the heat, it becomes the soft, and by applying the hammering or by applying some pressure, that is going on here the expansion. So, from this we clear that if some temperature will be the supplied, then it's the length will be the increase. So, if the conductor of the length here the L and we are supply here the temperature, suppose L is the length and we are taking initially that is equals to the L0, or you can say for the resistance that is the R0, means this is the initial resistance at 0 degree Celsius, and we supplied the temperature up to your the T degree Celsius. So, this is equals to final resistance at T degree Celsius. So, these two are its the resistance value, because this resistance is proportional to L. As per in your the first year for the thermal expansion, you know that L0 and LT, these two lengths we have taken. So, from that we clear that LT minus L0 is proportional to L0 and proportional to your the del T. So, here length is related directly with the resistance. So, if R0 is the resistance, means its corresponding length will be the L0, as we know from the Ohm's law. So, this is equals to your the R0 and this is the RT. So, it shows that RT minus R0, which is the change in its the resistance, is proportional to original one and its the change in temperature, that is equals to your the del T. So, this shows RT minus R0, if we make equalize, then that is R0 del T with some constant, that is the alpha. So, this implies RT is equals to R0 whole into 1 plus alpha del T, where this alpha is known as your the temperature coefficient. temperature coefficients, and its value for almost of all metals, that is equals to your the 1 by 273. So therefore you can say RT is equals to your the R0 whole into 1 plus 1 by 273 into del T. So this shows that if the temperature change in temperature to be or the more, then the resistance to be or the more. So this we concludes that as the temperature will increase, the resistance value will your the increase for your the good conductors. And from there we also clear that if this del T is the change in temperature is minus 273 degree, means that is your the absolute 0, then minus 273, this 273 is cancelled, 1 minus 1 is equals to 0. So this resistance at minus 273 becomes 0, and that is known as your the absolute 0 temperature. Now we are going to discuss about the electrical energy. You see, it is the combination of the two words. One is the electrical, second one is the energy. About the energy we know very well from your the class 9th, and in every subjects there is a term comes here, the energy, work, velocity, speed, these things are coming. So this electrical energy, so what is this energy? It's the fundamental one. Energy is nothing but the ability of doing work. If that energy means that ability of doing work is going on due to the application of the electrical circuits, then that is known as the electrical energy. So whatever it may be, if it is due to the electrical, then it is the electrical energy. If it is due to thermal, then that is the thermal energy. So electrical energy is defined as the ability of an electrical circuit to produce the work by creating some action, and the action which we have to create, that is your the work, and that action we are inputting, or that actions we are converting into in the form of it's the thermal one, or in the form of the electromagnetic, in the form of the mechanical, in the form of the different ways. So what amount of the energy that we are using or we are converting, that we have to discuss. So if we go for it, see the mathematical one, you see energy. Energy, what I said, if energy is your the E, that is nothing but your the work done. That is nothing but your the work done. So work done means that is equals to W. And this work is done due to your the electrical system. So this work, how it is related with the electrical system, we have to discuss. We know that V is equals to your the W by Q. W means your the work, Q means your the charge, V means your the potential. So when the electrical system we are saying that saying means some potential difference we are applying. So if potential difference is V, W is the amount of the work done, Q is the charge, therefore W is equals to your the VQ. So this W is equals to your the VQ. And this can also be written Q is equals to your the IT, because you know I is equals to your the Q by T, so Q is equals to IT. So E or the W, that is equals to VQ or your the VIT. Or you can also say I is equals to, you know, V by I, that is equals to your the R. So I is equals to V by R. So instead of the I, if we put V by your the R into your the T, so that is equals to your the V square by R into T, means W is equals to, this W is equals to your the VIT, this is the VIT, or V square by R, or that is equals to your the VQ. This amount of the work is done in your the electrical system, which depends upon the various factors. What are the factors? Potential difference, resistance, and the time here. Potential difference, time is there, but here it is the resistance if the current is applied. This is the potential difference with here the charge. Potential is there and the charge is there. Here is the charge, here there is no charge, here there is no charge. Here it is your the time, here is the time, but here not time. So depending upon the various factors which are supplying to our the circumstance, according to that the work to be done. So when this work is done, whenever a work is done, the energy is producing. Very common example means that energy can be used in the thermal or the electromagnetic different. Suppose for the thermal, if you rub your the two hands, this is one type of the work. So when this work is done, you will feel that some heat is the producing. So if the work is done here, then the heat is also produced, the electromagnetic energy is also produced, the mechanical or the different types of the energy. So this is it's the mathematical expression. Then comes what will be it's the unit. So unit of the work. Work means the ability of the doing work means energy, and the common unit we are using as your the joule. But when the more work is done, that amount of the joule is not used. In that case, it is used as your the EV. EV means electron volt. Electron volt, which is written as your the EV. So what is that? EV means electron volt means when one electron is able to produce the potential difference of the 1 volt, due to that one the amount of the work which is produces, that is known as it's the energy, means that is the electron volt. Then what is the value of this electron volt in terms of its the joule? Means 1 electron means it is a charge. Charge of the electron is 1.6 into 10 to the power of minus 19 coulomb. And this is the volt, I said that is the 1 volt. So here it is the number, here it is the number. If we multiply the number with the number is 10 to the power of minus 19. Then comes here the CV. So C means here the coulomb, V means here the volt. You see V is equals to here the W by Q. If V is equals to here the volt, W is equals to your the joule, C is equals to your the coulomb. So this joule is equals to your the coulomb into volt. So coulomb into volt is equals to your the joule. Therefore that is equals to 1.6 into 10 to the power of minus 19 joule. Therefore 1 EV is equals to 1.6 into 10 to the power of minus 19. My students, are you writing this one or not? Or only you are looking for the screen? So you look for the screen and the simultaneously either it is possible to take your the touch screen or your the you will to write it. So 1 EV is equals to this much. So this is equals to your the electrical energy. It is it's the unit, it's the joule or your the this one. Then what is it's the dimension? Dimension, I do put this formula or this formula or this formula, whatever may be the formula you will apply. This is the work. Energy means it is the work. So work dimension is ml square t to the power of minus 2. So this is it's the unit, this is it's the dimension. Then the question comes, this electrical energy where we are using? Generally when our house is there and in our country, each and every houses according to the government statement, they are getting the electrification. So when the electrification is coming to our the house at the end of the month, we are giving some amount or we are paying something for our the system. So what is that one? Now means what amount of the energy we utilized. So what amount of the energy we will utilize, that is your the kWh. That is called the 1 unit. 1 unit. So in your the housing system, 1 unit means suppose a bulb or the fan is going on or it is your the functioning day to day, then we are saying that kindly switch off that one because it will consume your the more unit. So 1 unit is equals to your the kWh. So 1 kW means that is equals to kilowatt. Watt is equals to your the power and h is the time. So P into T will also your the joule or the energy we will discuss later. So this is equals to your the electrical energy. Next we will go for the electrical power. So electrical power generally we are using as the P. So P is equals to your the W by T, it is the fundamental formula. So if P is equals to W by T, you see W is equals to either VIT, so this is equals to VIT by your the T, or this is equals to your the V square R by your the T, so V square by R into your the T, or another one is also your the VIT or the V square I by T by your the VQ. So if this TT will cancel by your the T here. So this is the W value, this is the W value. So T cancel. So this is equals to Vi or the V square by the R. So P is equals to the either Vi or the V square by R. But if you will go for the fundamental one, if P is the power, then that depends upon the work with the time. If the work is the 1 joule and the time is equals to the 1 second, then the power is equals to the 1 joule by the 1 second, that is equals to the 1 watt. So the fundamental unit of the power is the watt. So we are using this bulb is the 60 watt, this bulb is the 9 watt, this bulb is the 20 watt, this fan is the 60 watt. So that watt is nothing but that is it's the power. So power is equals to the watt. That is the smaller unit. If we go for its higher unit, that is equals to the kilowatt, kilo not kire, kilowatt, kW. One is the megawatt, not megamart, that is the megawatt, that is the MW. So kilo means the 10 to the power of 3, mega means the 10 to the power of the 6. So this is it's the unit. Likewise, you can find out what is the dimension, and the most common one for the higher cases, that is known as the unit is the Hindustan Petroleum. This is not the Hindustan Petroleum, this is the horsepower. So this horsepower means this power is the much more like the horse, therefore this is the horsepower. This is the unit, and I am giving you the time to calculate what is the dimension. So as we discussed in our the last class, that what is the electrical energy and the electrical power. So in my the previous classes, I said repeatedly, when we are going to know about the physics or chemistry or whatever be the subject, we are only having one of our the aim, how we will make a well position in your the entrance examination. So in the entrance examination, the vital portion taken by your the numericals. So every numericals can be solved, as I said earlier, if you remember the Pandava formula. About that Pandava formula I told earlier, and for your the remembrance I am saying Pandava formula means there are the 5 steps. One step is your you go through the question and understand its the meaning in your own language. Second one is a problem means something must be provided. Third one is the something must be asking. The fourth one is the supplied data are in the same unit or not, which is the most important, which is called sabse bada khiladi, not your the Akshay Kumar, that is the sabse bada khiladi. And the fifth one is the put the formula and get the answer. These are the 5 steps. So the 2 problems on the screen you are looking. Let us now go for your the first problem. How many electrons flow through a filament of a 120 volt and your the 60 watt electric lamp per second? This is the question. How many electrons means number of the electrons you have to calculate. Having your the potential difference of the 120 volt, 60 watt, watt means it's the power of that electric lamp, and the time is supplied, that is the 1 second. So how we will proceed? After reading through your the question, you will have the second step. For the second step, what are the data? The first data is your the potential. Potential, its symbol is your the V, so that value is the 120 volt. Next, it is given the power of that bulb. Power is equals to your the P, that is your the 60 watt. The third one is supplied, that is the time. Time is equals to your the T, that the time is your the per second, means that is your the 1 second. So these are the 3 data which is the second step. The third step is what is asking, how many electrons. So number of electrons is asking. That symbol is either small n or capital N, whatever may be the symbol you will take, and that we have to determine, that is equals to your the question mark. So these are the third step. The fourth step is that they are in the same unit or not, means all are in the MKs or CGS or not. You see volt, that is in the MKs, watt, that is your the MKs, second is the common one, therefore they all are in the same unit. So there is no need for the conversion. Next we will go, what is the formula regarding to that one, means we are interested to find the number of the electrons, means that is equals to your the N. So here the P, V and your the T is given. So we know P is equals to your the V square by your the R, or the P is equals to your the VQ. P is equals to your the VQ and Q is equals to your the NE. So, if power is there, the power is supplied, the potential V is there, but the resistance is not required, but here the time T is asking. So, P is equals to fundamental one is W by T, but P is equals to W by Q, W is equals to your the VQ. So, VQ by your the T. So, if V is supplied, you put the value of the V value is equals to the 120. So, here we put the 120, then it comes here the T value is equals to the 1 second, and this power P is supplied, that is equals to the 60. So, Q is equals to, only unknown is equals to the Q. So, Q is equals to how much? That is equals to the 60 by the 120, that is equals to Q. But Q is not our the question. The question is what is the number of the electrons, and we know that Q is equals to the Ne. So, Ne is equals to the 60 by the 120. So, N is equals to the 60 by the 120 into the E. E is what? The charge of electron. Put the value of the charge of electron. So, 60 by 120 into 1.6 into 10 to the power of minus 19. If you solve that one, then you will get the value of the N. Then it is okay for your the question number 1. For the question number 2, calculate the current flowing through a heater rated at 2 kilowatt. What I said, that is the unit of the power. So, that power is equals to 2 kilowatt and connected to a 300 DC supply. So, DC supply of the 300 volt. So, that is equals to your the V will be the 300. So, that is equals to 300 volt. So, P and the V is the supply and calculate the current through it. Current means your the I is equals to question mark. So, this is your the second step as per my the Pandava formula. This is your the third one. The fourth one is they are in the same unit or not. You see, this is the kilowatt. It is not the unit of the watt generally. So, now you have to convert into the watt. So, that is equals to 10 to the power 3 means kilo means 1000. So, that is equals to 10 to the power 3 watt, and this is equals to volt. This is the M case, this is the M case. So, now they came to your the one system. So, now you have to put the formula and we have to get the answer. So, these P, V and I, how they are related? You see, the P is equals to your the, you know that is equals to the VI, because P is equals to your the VI, we have written and we know that one. So, VI. So, if the I is asking, so I is equals to your the P by V. P, not your the drinking P. So, that is the power P. So, that is equals to your the 2 into 10 to the power of 3 by your the V is equals to your the 300. So, though this is the current, means this will be your the ampere. Now, you solve, find the value, the solve value or the calculation value is here, and go through your the problem and go through the way, that is our task. So, this is your the numerical, 2 numericals are the over. So, if you remember the mathematical expression, then you can find out it easily. So, this is your the numericals. So, if more numericals are required, you go through your the task book or the various books are available in the market, and as I said the Pandava formula, you make the Pandava formula. Next comes your the cell. You must heard the name of the cell. So, generally we are saying, suppose the telephone nowadays some are saying that what is your the cell number. So, is it your the correct one? The cell number. Inside your the mobile, there is a cell. That cell has its the separate number. But the person who is asking us what is your the cell number, we are saying our the mobile SIM number. So, this type of the mismanagement we have to avoid. So, there we have to use your the cell. Likewise, the cell is known as your the battery. That is, you are saying it is the battery. So, what is a cell? It is an arrangement or the device through which something to be or the pass. So, if you have a cell, that cell is of the two types. One is it's the primary, and if we next go higher, that is the secondary. So, the primary cell is there and the secondary cell is there. So, primary cell means generally which you are using in your the remote or in your the torch light, that are called your the primary, means they have not its the reuse. Once it completed its the storing capacity, it is over and we are throwing that one. So, that type of the cell we are calling as the primary. But for the secondary cells, that can be regenerated the energy, like the batteries which are using in your the motorcycle, car, truck, bus, in the various purposes. In your the home also you are using your the because the alternate of the current, which are saying that is your the inverter. In that inverter we are using the battery. So, that battery can be your the reused that one, and they are called it's the secondary. So, whatever it may be, it has your the two electrodes. Every battery or the cell, they have your the two electrodes. One is termed as the positive and one is the negative. So, when you will purchase a battery from your the any from shop, you will find that at one end there is a plus sign, at another end there is a minus sign. That plus and the minus sign shows that one is the greater in and one is the smaller in size by your the straight lines. So, if it has your the some electrolytes inside that one, means some chemical reactions are to be happening inside that one. If a battery will remain for some times or the years and years, you will find that some waters or the some weights are found on its the surface. They are its the chemicals ones. So, these chemicals are produces here the electrons, and the electrons will flow from its the negative terminal towards its the positive terminal. So, the direction in which the electrons will flow, in its opposite direction the current will flow. So, if the current will flow from the positive end to the negative, the electrons will flow from the negative end to the positive. That is called here the cell. So, if that cell is connected through a circuit, suppose this is a cell, we connected with a circuit, and this circuit have here the resistance R, and suppose we have a key here. When this key to be the pressed, then this battery to be the charged. So, when it will charge, it will produces your the currents. That never produces the charge. It makes your the creates the flow of the charge, but it produces the current, and that current will flow from your the positive end towards your the negative end, and it will pass through your the resistance as per our the diagram. This resistance can be replaced by a bulb, it can be replaced by your the fan, and that can be replaced by your the any type of the electrical instruments we are using. So, they are functioning on your the cell. But when this cell is in its the position, means they are closed, then that type is called its the potential difference. When it is not here, the only the battery is there, it is not functioning, means the circuit is not here the completely closed, then that one is known as the EMF. That one is known as the EMF. EMF means electromotive force. That is the electromotive force. So, electro means the term for the electron, motive means here the some motion, force means something to be the enhance its the working function. So, means if it is electromotive force, from today you clear from your mind that though the word force is there, it is a force, but it is not a force. It is that agency which helps to move the electrons through the circuit, then that is known as the EMF. So, and the EMF, this is your the cell when it is the closed position, that will produce your the potential difference. Potential difference, which is also known as your the terminal voltage. Known as your the terminal voltage. Means if we will go for its the chemistry, suppose what is its the chemistry 1. Let us, this is a container, and these are the two electrodes, and this container is supplied with the some solution, that is known as the electrolyte. And if these two ends are connected with your the a resistor, then due to the chemical reactions, these electrolytes will make its the exothermic. reaction. So, one is the exothermic, one is your the endothermic. Exothermic means which provides, endothermic means which absorbs. So, it produces the exothermic reaction. So, due to these electrochemicals which are present inside that one, they together make the exothermic, means they will produce the energy, and that energy will able to store the positive ions in the one electrode and the negative ions in the another electrode, and this positive to negative, it will be the flow. So, the flow will be the continue from positive end to the negative end. So, due to this, when an electron is coming here, and if an electron will be placed here, this is the electron. So, where the electron to be the go? So, there will be a repulsion between that one. So, what this electron makes? This electrons is only able, means it acquires the charges. This electron will acquire the charges, means it takes a carry back, it acquires the charges and it moves. And when it goes to the resistor, means we have a bulb there or we have a fan there, then that energy will be supplied there, and that electron comes, my energy is the gone, and let us now fill some of the electrons inside my bag, and by taking that bag, it is going from one position to the another position. This is its the chemistry portion. Therefore, when this is not the operated, then that is known as the electromotive force. After operation, what it provides, that is its the potential difference, means you see, here it is the battery and here it is the internal resistance. A cell is represented by likewise by this one or with a resistance. This resistance is the internal resistance which is present inside that one. So, this figure will indicate for your the EMF one, and this one will produce for your the potential difference. Across the two ends, it will produce the potential difference. So, EMF is your the E, potential difference is the V. So, out of these two, which one will be the more? You just think over that one, then we will discuss what will happen. Now, we are going to discuss about one of the most interesting which you are using in day-to-day life, that is your the grouping of the cells. I said earlier what is the cell and what the cell provides. It provides EMF and the potential difference. The EMF is there when the circuit is in the open position, and the potential difference is there when by using that cell we close the circuit. Now, we are going to discuss about the grouping of the cells. So, grouping. So, what is the meaning of the group? Being you are the +2 science students, you know, and you are using the group either in the physics or in the chemistry or in the botany or in the zoology, you are using the group. Group means in our language that is called your the dala, goshti. So, when a number of the similar things are taken together, then that is known as your the group. So, here the grouping of a cell, grouping of the cells. So, when the cells are taken, as I written, for the cell you will use this symbol also, or you can have due to its the internal resistance, as the chemistry I said earlier, if it has its the internal resistance and this is your the cell, this is for the single cell representation. Very simply you can write this one. So, this is the cell representation, and this is also some students they are writing it is the cell, but this is not the cell. This is one type of the symbol, you know, my dear students, that is the capacitor. For the capacitor, the two straight lines of the same size, but for the cell one is the bigger, one is the smaller, and it may be your the smaller, it may be your the bigger. So, this is your the cell. So, grouping means more than one cells. So, that grouping of the cells is divided into the two types. One is the series, another one is the parallel. So in the series in our the common language we are saying that is the pankti. In your the villages you will find that there is a pankti bhojana, means the the peoples will sit one by one, means basiki jo khaiba, that is the pankti. So this is the series means. Also suppose you have the cricket series going on, means series means there are the three one-day series or the three types of your the 2020, likewise the series, the 5 set, the 3 set or the 7 set series, means one completes, another one starts there. So when the grouping is makes in that way, that is the series, and in the parallel means they are of the similar size and placed one by one. So if we go for your the series one, series means suppose this is a cell, this is your the cell, and this is your the cell. Suppose I have taken the 3 cells. Either if you will omit this one, that also be represented as the cell. If I omit this one, then inside this I will write it's the internal resistance. And if you will never write here, and you can make it's the internal resistance. So that choice is your, which one you will accept, either this one or the latter one which I have done. So if they are series means, so this is the one battery, it has the positive and the negative, this is the positive and the negative, this is the positive and the negative. Series means the one end of your the first cell, whatever its the nature, it to be connected with the opposite end of the second one. You see the first one, it is the negative, it is connected with the positive of the second one. The positive, the negative of the second one is connected with the positive of the third one. If this process will go on, then that is called your the series grouping. The cells are said to be in the series when the negative terminal of the one cell is connected to the positive terminal of the next cell, and so on, and this is the series, and they being connected with your the external resistance of your the R. So now we will find that when this key to be your the closed, as we discussed, then the flow of the electron to be continue. When the electron to be flow of the continue, the current to be your the flow. And if the current to be your the flow means this is the positive, this is the negative, suppose the current direction will show in this way. Because here I have taken positive, here it is the negative. If I have taken this is the negative and this is the positive, means if this is the positive means it becomes a negative because it's the opposite end. So at that case the direction will be the different. So that depends upon the arrangement of your the cells terminal. So if the current is flowing here, that is equals to your the I, you know I is equals to your the V by R. V means your the total EMF by your the total resistance. Total resistance. This is equals to the net current which will flow through this one. So if this is the total EMF means it connected with your the number of the cells of the similar type. If it has the EMF is equals to E, and if we have your the n number of the cells, n, here I have taken the 3. If you have the n number of the cells, then this is equals to your the total number of the cells, that is equals to your the Ne by your the resistance. Resistance means it has its the own resistance of your the internal resistance R each, and this is the external one. They are connected in your the series. So when the resistors are connected in the series, the net resistance is equals to the sum of the individual resistances. And if there are the n number of the resistors, then the total internal one is your the NR and the external one is the R. Here it is the R. Suppose it has the N, then this is equals to the NR plus R. So I is equals to your the Ne by your the NR plus of the R. So now we have to consider the special cases. How it will give you the various results. Special cases. Suppose we will go for your the first case. Your NR is greater than R, and the second case the NR is less than R. Suppose this NR is much greater than, suppose you will take much greater than, if this is much greater than of the R, means the sum of the internal resistances is much more than that of the external resistance, then this external resistance is also neglected. So it will becomes here the, then I will be here the NE by here the NR, NE by here the N small r. So now N is cancelled, so this is equals to here the E by R. E means here the EMF, R means here the resistance. Whose resistance? It's internal resistance. So internal resistance of which one? Only R is there, means for a single cell. So this E by R is the current, because EMF by the resistance is the current. This is the current of a cell. So this is the current due to a cell. This is the due to a cell. When NR is much less than of the R, NR is much less than the R, then this value will be the only R. So NE by the only R, much less I am saying. Suppose there is a ocean. So on the ocean, if we drop a bottle of the water, can it see the height will be rise? Nothing. From the ocean, if we take a trunk of here the water, can its the height will be down? Nothing will happen. So if this one is the much more than of the R, the much more thing will be remain. If this one will be the much more than that one, then that thing will remain. So if R is much greater than of the NR, then we will say that this current I is equals to NE by R. So that is equals to here the N of here the E by R. So N is here the number, E means here the EMF, R means here the resistance. So that is equals to here the N times that current due to a cell. N times that due to a cell. So if you have a grouping of the resistors in the series and they to be taken in its the different ways, then the number of the currents will be the vary. So by taking this one, most of here the persons who are treating us in your the different way, they are saying that due to the some blessing of the God, now I can change the value of the current in this series. So at that case, what they are doing? Either replacing this capital R, value is the much more or the much less, then the amount of the current which is produced on the same segment, that will either increase or that will the decrease. So likewise the layman's, they will think that that is the blessing of the God, so they are going to that, to their side. So if we will go the detailing about the something, then we can help for our the society. So thank you very much.